Hi, this is Owen Rubel here to talk to you about my development in HTML5 and the Akihabara framework. For those of you who have been following this video series, I am working in my spare time on an experiment to build a Morpeg in HTML5, working with the Akihabara framework. And in this latest series, I have introduced you to an A-star library that was introduced to me by some other people using the Akihabara framework over at Boston Game Jams. What the A-star A-star is basically an algorithm for pathing, allowing you to well, for instance, have enemies that follow you around, that will track you if, say, for instance, they go aggro. So, oops, well, we had a little problem there. We're gonna reload. As I said, I'm still in development, so not everything works perfectly. But here we go. We're going to go back in here real quick, and in this cave here, there is a skeleton. He tracks really well. In fact, he tracks a little too well. And excuse the graphics, he flashes a little bit here and there. It's a little jerky. I'm still working on some of the tracking, but in the last video, I had some problems with the tracking, and especially with on this next screen that I have several sheep on this next screen, and they basically all tracked and followed me and would combine to one XY coordinate, creating one super sheep. And that was the problem that I had to overcome. And so, let's show you what I came up with. This is the fun part, showing what we came up with. Well, more errors is what we came up with. It's hard working with JavaScript. All of the stuff has to load completely. But this is my fault for not having checks in place for all of this stuff to load. But I'll work on that as I go. Like I said, work in progress. So, as you can see, the sheep will follow me. I gotta get on by these guys. And they're a little jerky because of some stuff I added for checking for collisions with the other sheep, but that was very important. They have to check for collisions with their fellow sheep and readjust. And some of the readjustments are a bit jumpy. When they get really, really close, they get quite a bit jerky. But they track amazingly well. And I just really wanted to show that the tracking issue and the issues with their collisions with each other have been basically solved. Now, the question is, how did we solve that? Let's go back over here and see if I can trap them. So, there. They're trapped. They'll stick right there for the time being. So basically, how we solved that is that each individual sheep, there is a while loop for the tile collision, or for the enemy collision. That as it's going through setting its XY coordinates, each time it goes through, it checks for a collision when setting the XY coordinate. And if it detects, the very first thing is, while there is a tile collision, keep looping keep looping through this. And in that loop, we set the XY coordinate. But if the XY coordinate doesn't work, we say, try another direction. If that direction doesn't work, why not try standing still? Maybe standing still will work for you. Just for this turn, just for this tick. And I'm still experimenting with that, trying to get different variations on that. But that seemed to work best, going through that loop, checking the collisions for these guys. And the other thing that I had to do is there is a waypoint max that works with the nodes that allows me to set the number of nodes that each enemy is working with. The lower the number of nodes, it can easily get stuck. But you want a higher number of nodes. The higher the number of nodes, the harder it is for them to get stuck. But you don't want too high then, because then there's this, it's harder for it to track. So you want to find a good balance, so that they can track, not get lost, but at the same time, you don't want them wandering all over the place. And here we go. There. Now I've got them trapped. That's a great way to trap them. Just about on any more peg, unless you've got really good AI, then they'll actually walk around. But I'm not going to build that in. So again, that's the solution. Really easy. Wanted to show that got that up, got that working. Probably in the future we'll build that out a bit more to have it not so, as you saw, it was chuggy. They jumped quite a bit. I'll probably do one more segment on this to show them working a bit more smoothly. But it is working, and they can detect each other. They're not running into each other. They are readjusting their path. Like I said, I'll probably do one more segment on this to probably see if I can make it a bit more intelligent, and see how that goes. I'm not sure how intelligent you can make A star be, but at least you can get it to be smooth. So that's it for this segment. Hope you enjoyed. Again, check out the Akihabara framework if you have time, and see what you can build with it. Thanks a lot. Take care. Bye-bye.